Renite Company presents a motion picture showing some of our developments since 1930 in the lubrication of forging dies and tools. Developments which have helped to improve the quality and to reduce the manufacturing cost of forgings. We develop, manufacture, and engineer special lubricants and release agents, as well as practical manual and automatic means of applying them. We took all of the following motion pictures in a number of factories. You are looking at a forging press making an aluminum structural aircraft part. The operator is using a lightweight Renite hand spray gun to apply a special kind of Renite on every portion of all die surfaces over which the hot aluminum is worked. The press has been slowed down to provide a clearer picture of the complete operation. Renite has been mixed with 10 to 20 parts of clean city water before being spray applied. It will not lubricate while wet. Rather, it must dry immediately so as to plate the surface. Gas burners have been installed on the dies to bring die temperatures up to between 300 and 600 degrees Fahrenheit. This temperature range must be maintained in order to drive the water off as steam and to leave a dry Renite plating over which the aluminum metal will move, fill, and release. You will notice the complete absence of smoke and die explosions. Special manual and automatic spray equipment has been developed to properly plate dies and tools with these instant drying Renite lubricants. The Model G20 atomizer weighs 6 ounces and sprays Renite supplied by gravity in 2 directions with interchangeable patterns. Regulation of spray quantity to either side is provided by adjusting separate needle valves. This Model G20 handgun has tubes long enough to enable the operator to reach all die surfaces without getting his hand under the die block. Renite is closed to atmosphere from the nozzles back through the handgun to the supply tank. Compressed air actuates a small internal flow control valve directly behind the nozzles. Different spray pattern nozzles are easily inserted into and removed from the atomizer. We have also developed automatic moto spray units which apply Renite uniformly to die surfaces by reaching into parted dies, then spraying in a pre-adjusted pattern and returning to the starting position, all as fast or as slow as the job requires. Speed of reciprocation is regulated by a speed control valve. You can have any number of atomizers from 1 to 5 in any position or combination of positions and with various spray nozzles. Renite is supplied by gravity. Units can be mounted horizontally, as you see here, or upside down if necessary. Stroke, spray timing, and spray duration are easily regulated by adjusting control cams. The unit requires 80 to 100 pounds air pressure. Also, units can be mounted vertically. They will automatically operate through a complete cycle by hitting a palm, foot, or cam actuation valve. Motospray is a rugged, powerful mechanical pneumatic self-lubricating unit. Here you see a unit with others in the background which has been in operation for over 8 years. Mounted vertically on a forging machine known as an upsetter, and automatically spray lubricating the die cavities. The die opening is quite small, and special Renite atomizers had to be developed to provide the proper spray pattern while reciprocating down into and back out of such a restricted die opening. Hot steel is being worked in 5 different cavities as the stock progresses downward in the upsetter. Moto spray moves downward automatically, spraying the opposite die cavities as it passes them until reaching the desired point where it automatically reverses, spraying the die cavities again as it comes out. Moto sprays can also be made to automatically lubricate die cavity surfaces as well as tools on the header, which cannot be shown in this particular picture. Here you see a small moto spray mounted horizontally in through the left window of a forging press, and spray lubricating the dies automatically after every forging cycle has been completed. The operator is tongue feeding small billets into the press, which forges a socket in one pass and then automatically kicks the forging into a container out of sight of the camera. Motospray moves in to lubricate the punch in the top die and the cavity in the lower die after every kick-out cycle. 3 model G20 atomizers are affixed to this particular motospray. Outboard atomizer nozzles converge their spray upward on the sides of the punch, while the centered atomizer sprays the punch as well as the die cavity. Timing and duration are set for a short spray application. Renite provides proper lubrication and release as well as punch cooling and cavity cleaning when applied with motospray equipment. Motospray is mounted at the back of this particular forging press in another factory. The reducer roll operator passes the hot preformed steel rod into the press operator, who forges the steel through blocking and finishing die cavities. The forging is then thrown out onto the conveyor belt, where it travels to a trim press and is trimmed hot to form a component part in automotive steering linkage systems. As the operator throws the forging onto the conveyor belt, his tongs hit a small actuation switch that activates motospray through its complete cycle as seen here. Atomizers spray, lubricate, and cool the punches or plugs in the top die, while cleaning scale out of bottom die cavities at the same time the lubrication takes place. Once the best spray pattern and dilution of Renite are worked out for any operation, Motospray repeats the application cycle after cycle. Quality of the forging is improved, production is increased with die and tool costs less. Here you see Motospray mounted at the back of the press and moving between the dies toward the operator. There is an important difference between Renite and ordinary lubricants, which simply apply a wet, fluid, waxy, or greasy coating to tool and die surfaces. Renite dries instantly on die surfaces, plating them with a completely dry, uniform, thin layer of lubricant that will not flow, puddle, or compress. The use of oils and greases, on the other hand, results in smoke, fire, and explosions. This means dirty operating conditions as well as poor die life caused by the forging exploding out of die cavities or off die punches. Tool or die surface temperatures must be low enough so that the Renite and water mixture will wet the surface for at least a fraction of a second, and hot enough so that it will not stay wet or puddle but will dry instantly on the surface. Low billet temperatures of aluminum forgings require additional die heat, as shown here. High billet temperatures of some brass and steel forgings, on the other hand, require additional die cooling by auxiliary air or air-atomized water sprays impacting the die surface to carry off excess heat. Here, Renite is being correctly sprayed against visible die surfaces. You will see the die taking on a dull gray-black color. This becomes a black shiny polish as seen as the forging is made. All pinpoints on the die must be coated to provide release and to prevent the die steel from oxidizing. Such a surface then provides excellent lubrication, but is a dry, non-wet, non-oily surface that can be varied to control metal flow. Die lubrication with special Renite water-based materials does require an adjustment on the part of operators to a new feeling and a new experience, but the production results are well worth the effort. As examples of these production results, Renite has been mixed with 8 parts of clean city water and applied by Motospray here in the forging of small aluminum fins. Notice how easily the finished forging releases from the die cavity by a small burst of high-pressure air from the copper tube on the left. Notice the dry, non-wet, non-oily Renite surface after spraying. Then the black shiny cavity after forging. The same kind of Renite is being used here to lubricate deep and difficult extrusion dies. In this particular operation, where metal movement is more pronounced and more severe, Renite has been mixed with only 3 parts of water so as to provide a very heavy die coating for more effective metal movement and release. Such a rich mixture will overcome surface temperatures of dies and tools well above 600 degrees Fahrenheit. Notice the heavy black coating of Renite on the upper ram sidewalls after spray application. This finished aluminum extrusion housing is approximately 30 inches long after being extruded from a round 12-inch diameter by 3-inch high donut forging seen in the bottom center left of the film. The aluminum donut is forged on this press. Renite is being mixed with 8 parts of water. The resultant mixture is supplied and recirculated under pressure to moto spray by means of a Renite tank and pump system seen on the far left side of the forging press. It is important to use good mixing and good supply systems for Renite water-based die lubricants and special Renite moto spray equipment. Easy, accessible mixing, continual recirculation, and fluid pressure at the atomizers result from use of inexpensive Renite model number 40 tank and pump systems seen here. Over the years, we have pioneered in the development of new and better ways to automatically spray lubricate dies and tools on all kinds of forging presses and machines, many of which we have been unable to show due to limitations of time and availability for filming. During the past 10 minutes, we have shown and discussed some of these ways in which Renite spray lubricants and special Renite spray equipment are playing an important part in improving the quality and reducing the manufacturing cost of forgings through scientific die lubrication. We welcome your further inquiries about these and other Renite lubricants and Renite spray developments, all of which are manufactured and engineered at our plant in Columbus, Ohio, where general offices are located. May we have your comments on this particular motion picture, as well as your suggestions for other such motion pictures in the future.